So we're back with part 3 of the tutorial using Microsoft Excel with Grasshopper. In the second part, we got rid of all of our sliders in this parametric tower massing and replaced them with cells in an Excel sheet that read the building height, the base width of the rectangle that defines this mass, base width and depth, top width and depth, so we get this pyramid, this kind of parametrically driven mass. And when we change the Excel, changes the it changes the form. So what we end up with here is this mass, and now what I want to do is look at how you can get data out of Grasshopper and back into Excel. So in my definition here, let's see, I have the origin. It's the point at the base, and then a top point. I can use this to make a line. I want a new parameter. Let's call it just a number. Let's call it num floors. And let's see, let's add here, say, number of floors. It's 8. And we'd fix that formatting if we were being a little bit compulsive. Where is it? Okay. Right, so that's going to be read from cell C9, the number of floors. Right. Here we're already starting at C7, so that's going to be C. There, I mouse over it. I need to hit recompute. There we go. We see we have 8, which is just what we want. Okay, so what we're going to do is we're going to assume an even floor-to-floor height. And I'm going to go ahead and I'm going to divide up this curve, right, that's this line, 8 times. Let's see, oops, expression n minus 1. Right, so what I get out of it are 8 points. And I can take those 8 points, make 8 XY planes, right, 1 for each of the floors, and let's just dump that to a parameter called floor planes. All right, and so here's our mass, and here's our floor planes. The mass is it's a B-rep. So what we can do is we can take the intersection of a B-rep in a plane, otherwise known as a section. You can see then what we end up with. Right, it's a series of floor plates. Floor plate. If we want to, we can make them a planar surface. And then one of the things that you notice here in the planar surface is an analysis component that will find the area. If I dump that to a number, and I flatten it, right, that's the list of the areas of each of the floor plates, and we can check it, right, because we know that at the base it's 90 by 40, so that means that the ground floor area should be 3,600, and it is. Right? So we know we're doing our math right. And the trick is now we'd like to just write it back to Excel. So let's just edit the Excel sheet here. Let's say 4, and say area in square feet. Right. We can if we go back to my palette of components that read to and write from Excel, right here at the bottom we have the set that will write a column of data. We want to make sure that's set to false, because when it's false it's not writing, and then we won't accidentally overwrite something in our Excel spreadsheet. So I'm going to copy, paste it in over here, and let's call this areas. Right, and if I hook that up, now where do I want to write it to? I want to write it to G3. Let's edit that. So G3. And if I just toggle that to true and then back to false, it should have written it, and it has. Right? And if I want, I can just do Control 1, make sure that's set to number in 2 decimal places so it reads nicely. And it would be nice also to automatically number the floors. So let's go back and do that. So one way of doing that would be just to create a series. I'm going to say we're going to start at 1. We're going to count by 1, and we want 1 for each of these numbers. One way to do that would just be to say the list length of that list. Right, that's going to be our count. And here, let's see. Actually, let's do it this way. So now they're both driven off of the same toggle, and we want to write starting at F3. Let's just hook up that count to here. Right, so now when I toggle, right now it's writing my area in square feet. And if I want to sum my total floor area, I could just do that in Excel. Call that total floor area. So if I now if I do things like delete this version of Tower 2, move or copy, and I'm going to create a copy. Let's call this Tower 2. Right? And what I'm going to say is, what happens if I change the building width to 100 at the base, and the depth to 60 at the base, and the number of floors, let's say the building height to 120, the number of floors to 9. Right, this is Tower 2. So since Tower 2 is my active worksheet, when I go back over here and I update, you can see the form changes, and you can see that now I have a total floor area for Tower 2 with these parameters, and this is my total for Tower 1 with a different set of parameters. And anytime I change anything over here and then recompute the definition, it's going to update the information here. So as a final idea, let's try this. You'll note that because of the way I'm because of the way I've divided up the number of floors, or the way I'm dividing this line, I'm getting even floor-to-floor heights. The first thing is, what if we just want to know the elevation at each floor? So I know that this point is at 0 in Z, and let's just assume that's always the case to make life easier for now. Right? This is the set of points along that line. What we could do is we can get the Z value, and we can call that floor elevation. And we can write that in. So let's write that in column G. Right? Oops, sorry, column H. So, elevation. So now if I toggle this between true and false, it means now I have the elevation in feet. Elevation in feet. For my for each floor. Right, that's tower 1, here's tower 2. Can do the same thing. Compute it. Oops. I didn't toggle back between true and false. Right, so this is set never to write when it's set to false, and that's so that you don't, change something accidentally and overwrite data that you really needed. It's just kind of a safety measure, which from experience I know is a good thing. Right, so here are your elevations for the floors, the floor heights for tower 2. Just update our formatting. So the last thing I want to do is let's say what you want to do now is to go back and manually tweak these and redo your floor-to-floor heights. You could do that. You could do it this way. You could go to the Read Excel, and here we have components that will read a row or a column until they get to a null value. I'm going to take that and copy it over back here. Now I'm freestyling a little bit, but let's see if we can get this to work. One thing I want to do is I want to set this, the elevation, the thing that reads elevation, to be on its own toggle, so that I can update the, oops, that's the wrong one. There we go, this reads the elevation. So that I can update the floor areas and number of floors without updating the elevation in feet. Because now what I want to do, now that I actually have values in here, is I want to be able to tweak them by hand. And the place that I want to read from is I want to read from column H starting in row 3. So if I go back over here, I set that to be row 3, column H. I'm now reading my floor-to-floor heights here. And up here, right, I decomposed my points. I think what I want to do So let's go and recompose them. The X and the Y from there, and the Z from our new value list that we're now reading from Excel. Floor height. Right, so right now they're the same. But what would happen if we were to do something like to say that floor 2 really starts at 20. And floor 3 really starts at 32. Let's say, I don't know, 40. And floor 4 starts at 50. Now coming back here, if I reread, right, you can see that now I'm getting a new set of points here. And I'm going to use those points and hook those up to make my floor planes. Let's copy all, move all this over here. Right. So once I do that, now I can manually shift these floors around. All right, I can say, all right, well, maybe floor 2 should be at 18, and floor 3 should be at 38. And of course, since my form is tapering, right, you can see that actually this has implications for the floor area. Right, so if I move or copy tower 3, and make a, or tower 2, excuse me, and I make a tower 3, you could see that, you know, if I change these, 15, 30, 45, something like that. Right. And then I toggle that to true and false. Right, that updates my total floor area. I go back to tower 2. Right, so these, right, you can see that's changing the values of the elevation of the floors. And update here, right, toggle that between true and false. You can see that now I have one floor area for the version with these floor heights, and slightly different floor area for a version where the floors are cutting the form in different places. So in this way, not only can you have multiple versions, multiple parameterizations of the same definition, but you can actually start to compare them, and you can compare them with data, and you can save them. And so you're no longer moving around a million sliders and trying to remember, you know, what was the set of values. You can just toggle back and forth between different worksheets.